Okay, so continuing right where we left off, X is midpoint of MN. Alright, NN is this segment here. So tick, tick. Then, whoever made this proof was nice enough to tell us, well, MX and RX are congruent as well. So they all have a single tick because they're all congruent to each other. Alright, and we're going to prove that XN is congruent to RX. Alright, and then how this proof is organized is typically how I don't do it when I do proofs by myself. But I organized it a little goofy just so you guys are aware of things. Notice how I have this given here. And what I mean by how it's organized goofy, stay tuned and find out. Alright. Next is we got the buzzwords. Alright, buzzwords. Alright, midpoint is a buzzword. Other buzzwords in the future will be like supplementary, linear pair, stuff like that. So, I have XN is congruent to MX. We already have this labeled. It was just by definition of midpoint. Def of midpoint. Alright, and again, it told me that there was a midpoint, so I'm going to use the definition of it. Now, this is what I mean by this proof's a little goofy. I typically don't do it, but you might see it on a quiz or a test or in the future. How do I know that MX is congruent to RX? It was just given to us. Alright, so me, I like to put all the givens up top, just get them out of the way. Sometimes people like to purposely place them, say, well, now it's useful to say that because MX is congruent to RX, MX is congruent to XN, so they must be congruent to each other by none other than transitive, which is a special form of substitution. Alright, so that's that proof tomorrow. That's that proof right now. I don't know why I said the word tomorrow. Alright, here's two more proofs in a little preview, and then you got all that fun stuff to do on Canvas. Alright, so look, this one's funny. It spells out the word chair. That's funny. You guys are probably sitting on a chair doing this right now. So given H is the midpoint of CA, so tick tick, I automatically know that. And then it's telling me CA is congruent to IR, so unofficially I like to put the squiggly mark just so that those whole things are together. When you put tick marks with all these dots, you get kind of confused. At least I do. Maybe I'm just not that bright. But anyways, that's our given information. So let's go ahead and write that down. Given. Alright. Then CH is equal to HA by definition of midpoint. Using our buzzwords. Midpoint, midpoint. Just kind of notice the flow. So as we progress through these two column proofs, maybe you're already starting to feel a little bit better, but it's just kind of one giant pattern, all right? There's really not that many unique proofs to do, whether it's segments or even angles, and it's kind of repetition, and you'll start to see things eventually. You might be there, maybe you're slowly getting there, maybe not yet. Don't worry, we're going to practice this stuff tomorrow. All right, so I used buzzwords. Now I can also use the picture itself, all right? I can say CH plus HA equals CA, CH plus HA equals CA. That's just a segment addition postulate. Alright, so I use buzzwords, I use the picture, now I can use previous statements. Alright, CH and HA are the same, so I can take this HA and swap it out for a CH. Alright, and that's just substitution. And then hopefully it's starting to fall into place where the CH plus CH becomes a 2CH by combine like terms or simplify. And then hold up. Oh boy. We have CA is equal to IR right here. CA is equal to all that junk. So 2CH equals CA, IR equals CA. So they must equal each other by none other than transitive. when two things equal the same thing, they must equal each other. Alright, and let's draw a picture of Mr. Vote. We haven't drawn him yet. Some people have Mr. Vote in class, some don't. He has a really good mustache. That's what he looks like. And he's in a good mood because he's doing math. That's Vote. Make sure you draw him on your notes. That's worth points, is drawing Vote. And then let's try to complete this proof from scratch. Alright, so again, it's just one massive pattern. Hopefully it's a pattern we're starting to recognize. But the more we practice these proofs, the more they start to fall in place and we start to realize what's going on. Alright, this is a big leap. This is a hard thing to do. I understand that. Alright, so before I even draw on my picture, I'm just kind of organizing it. A is midpoint of CS. AS equals SH, given. Alright, so I drew my two-column proof and then just filled in the first one. So realize, actually I'll talk about this at the end. Alright, now I'm going to draw my picture. A is the midpoint of CS. So ding ding, AS and SH are also equal, so I'll put another tick mark. So basically, by labeling our picture, we realize that all these minor segments are congruent to each other. That's pretty interesting. Alright, so what can I say from here? Well, remember I had midpoint, so I can say, well, CA is equal to AS by definition of midpoint. Alright, don't forget we have this buzzword. Alright. Then, let me pick a different color. Something we always want to finish with, and in fact we can just do on our third step, is say we want to finish with what we want to prove, and that's CA equals SH. And that's kind of funny, it spells cash. LOL. Alright. Cash. I got all kinds of cash. Anyways, AS is equal to SH. AS is equal to CA. So since SH and CA equal the same thing, they must equal each other by transitive. So we did this proof from scratch, and as you realize the patterns, you might realize, hey, the first statement in reason, it's just given to me and I write given. The last statement is just what I want to prove. So out of the three statements, two of them were basically 3 points. And just two of the reasons we had to figure out. Alright, so basically 3 out of the 6 stuff was predetermined. Alright, we'll notice these patterns more. We got some practice problems in Canvas for you to do. Don't forget to do it. And that's a little preview of the next lesson. Ooh, be excited.